Okay, this is question 4 from P4 January 2022. As you can see, it's going to be a rates of change question. And with these ones, I was getting a little bit panicky about this first part, about trying to work out what that is. Please be aware of the fact that if you can't get these 2 marks, and it is only 2 marks, we should certainly still be able to go on and do parts B and parts C. Let's have a quick look at part A then. They can be quite individual with these style of questions. What have we got? Horrible looking shape here. Regular icosahedron, and that's side length x, 20 congruent equilateral triangles, find the surface area. Okay, read it again, and actually it's not that bad then. I'm trying to find the surface area of 20 congruent triangles. So basically find the area of one of those triangles and then multiply it by 20. So find the area of one of these triangles. What do we know about these triangles? Well, let's get started and copy something down. So for part A, we know it's an equilateral triangle. Let me do my best version of trying to do an equilateral triangle there. And if I've got the equilateral triangle, then I've got x, x, and x there, and importantly, I've got that's 60 degrees in there. They're all 60 degrees. Okay, well, actually don't really want the bottom one there. If I've got that situation and I need to find the area of this triangle, I'm okay to make a start now. I'm going to say the area is half AB sine C. So the area is going to be a half x times x times sine 60, and then just tidy it up on your calculator. I know sine 60 is root 3 over 2. You can stick it into the calculator, but I'm going to get that as being root 3 x squared all over 4. That's the area of one of them. So the surface area is equal to 20 times that, which then works out to be 5, that's it, 5 root 3 x squared. And notice sort of almost like the surprise in my voice there, that will sometimes happen, that you'll go and just do what you can, and then all of a sudden, before you know what's going on, you've got the answer there. I wouldn't give it too much time if you don't get the idea fairly straightforward, fairly quickly, then just move on to part B. So what's part B saying? Part B is saying, if I've got that the volume of this thing is whatever they're telling me, 5 over 12, 3 plus root 5 x cubed. If I've got V in terms of x, can I find dV by dA? So for my rates of change work, what I'm always thinking of is, in this case, I'm looking for dV by dA. I can get dV by dx. So how do I make that match up with each other then? What I need to have is dA on the bottom and dx on the top, because then they will cancel out. Now, although I can't get dx by dA, I can get dA by dx and then flip it over. So that gives me a way of getting started here. What I'm going to do, I've got a formula for A up the top there. I'll have a formula for V, so I can work out dA by dx and dV by dx, and then I can chuck it into that. So let's crack on and get started with that. Again, a really nice way of getting some marks here by just saying, right, I've got my formula for A. Once I've got my formula for A here, which is 5 root 3 x squared, I'm going to differentiate that. Don't get confused by the fact that we've got 5 root 3 at the front. That's just a constant. It's just multiply everything by 2. So it's 10 root 3, take 1 off the power. If I've got V, what does V work out to be? V is 5 over 12, 3 plus root 5 x cubed. So again, that's not that complicated to differentiate. It looks like it's horrible, but all of that first bit is a constant. It's just multiply by 3, take 1 off the power. So it's going to be 15 over 12, 3 plus root 5 x squared. I can tidy up the fact that 15 over 12 is a fraction later on. So what did we say before? We said if I want dv by dA, that's dv by dx times by dx by dA. So in my mind, I already know that dx by dA is 1 over the other one. Okay, so if we're doing that, that's, let's sort out 15 over 12. 15 over 12 is 5 over 4. 3 plus root 5 x squared, and it's 1 over the other one, which was, what was that? That was 10. Root 3x. We just need to tidy that up when we're looking at it. Okay, so that's going to be, in fact, I'm going to let you do that rather than take absolutely ages to do that. You've got 5, 4, and 10 there, so that's 5 over 40, so that's 1 over 8, isn't it? So 3 plus root 5 over 8, and x squared divided by x is going to give me x in there. And there's a root 3, so I'm missing a root 3 on the bottom there. Move that over. So that's my dv by dA, is that what I was asked for? Yeah, dv by dA. Oh, sorry, I was trying to prove it's equal to that, so that's absolutely great. Part C. Let's highlight that. Part C, it tells me in the question now that the icosahedron is increasing at a rate of something or other. Look, there's a big clue here as to what that is. If it's centimetres cubed s minus 1, centimetres cubed per second, that must be area by time. So they're telling me that dA by dt is equal to 0.025. Make sure you use that little hint in future for other ones. The units can often tell you what we're trying to do here. What are we trying to find? Try and find the rate of change of volume. The rate of change of anything is always by dt. So the rate of change of volume is going to be that. How am I going to get that? Well, I've got dA by dt already there. So what do I need to times that by to end up with dv by dt? I need to have a dv on the top, and then I need to get rid of that dA. So I need to have a dA there. Oh, brilliant. That's what I've already got in there. So they've been really helpful there. Nothing too clever to do with that one. So dv by dt, this is going to be quite quick now, isn't it? Is going to be equal to 0.025 multiplied by dv by dA, which is 3 plus root 5 over 8 root 3 times x, and we'll know that it's when x equals 2. Okay, when x equals 2. So that, which then gives me a final answer of 0.019. Okay, hopefully that makes sense to you all.